Hello and welcome to Intuos Designs. We got a pretty special show for you tonight. We're going to be teaching you guys how to create a printed circuit board with a fiber laser. A lot of people are into electronics and, designing a printed circuit board and sending it out and waiting for it to come in is a bit of a hassle. So I don't know if you know this, but you can etch a printed circuit board with a fiber laser, and we're going to show you how to do that today. So without further ado, my name's Troy. I'm with Intuos Designs. We're going to turn on the laser cam here and show you a few things, explain a few things. Here on the laser deck, on the work deck, you're going to notice these black things right here. They are what's called fences. What they do is they bolt down to the work bed of the laser bed here, and they keep everything aligned. Okay, so one of the things you don't want to do is you don't want to leave the work bed bare, because the laser will carve into the work bed. You kind of don't want to do that. You might put a logo on there or something, but you don't want to keep carving into the work bed. It makes it very difficult. I have a base layer of a printed circuit board that is laying down there, and that is so that when the laser actually carves through the material, that it doesn't carve into the work bed. So the other thing that I have here in my hand is a square piece of a template, and that template or guide is what's going to hold all of our printed circuit board exactly where we want it. And the fence keeps everything square to the laser head. And so that's what this is. Okay. So these are the printable circuit boards that we're going to be printing on, and they are double-sided, okay? And we are going to etch out a double-sided printed circuit board with a fiber laser. It doesn't take very long. You got about 10 or 15 minutes, and it'll be totally finished up. And, we're going to show you a few other things that you have to do. You have to have what's called a solder mask. And you can see these are finished ones that I've already etched out and everything. And they've already been coated with the solder mask. And then we're going to show you guys how to remove the solder mask with the fiber laser in the areas that you need. So the process is etch the board, turn it over, etch the board again, take it off, then you apply the solder mask. Then after the solder mask is cured, and that's done with a UV laser, a UV lamp, and then you drill the holes. You come back to the fiber laser and you drill the holes where the holes need to be for the pins of the electronic components. And then you remove the solder mask from the pads where it needs to be removed. So we're going to go through all that really, really fast. It's not going to take very long. It's really cool to watch this because there's a lot of sparks and a little bit of fire and some really, really cool things. I have my cat here, and I got to get my cat to go out because I can't have her around the laser. Anyhow, I am very sorry about the light behind me. It's so that you guys can see what's going on the deck of the fiber laser. I'm trying to figure out another way to get lighting in here. That way, it's not glaring at you guys. So anyhow, without further ado, we're going to show you the program that we use is called Lightburn. And Lightburn is not, for just making printed circuit boards. It's everything lasers. It is probably the best. It is the best software to utilize for doing any type of laser work. CO2 lasers, galvo fiber lasers, any gantry laser, anything like that. It is a very superb software for doing any type of laser work. So I'm going to go through some of the settings and everything, but I want you to understand that every single laser is different. You can actually have the same exact laser from the same exact manufacturer, the same lens and everything, and your settings are actually going to be a little bit different because everything is unique to each individual setup. Humidity, air temperature, everything. It really does matter. So what my setup here is I use a COM marker, a B6 60 watt MOPA laser. It's to me, I think it's actually a superior product to many others. I like it a lot. It's very simple to use. Really, honestly, getting used to light burn is the difficult part, and understanding light burn and how light burn works. So we're going to go ahead and we're going to load our project here, and what we are going to do is I'm going to go ahead and show you what's going on. So this right here is light burn. This is our project. These over here are all the layers that are required to make this board. Okay. When these switches are green up there in this area, when they're green, they're turned on. When they're red, they're turned off. Okay, because obviously we don't want to use all of the layers all at the same time. So I'm going to go ahead and turn off all the layers. And the way that this works is that each layer is actually done in order. So the topmost layer is the one layer that's going to be first. So the one thing, I'm going to go ahead and move this board edge cut all the way down because we don't need it, and it would be the last one anyway. Okay, so with that said, we're going to go ahead and we're going to cut the front. So we're going to remove copper from the printed circuit board, and we're going to go ahead and turn on that layer, and we're also going to turn on the outline of that layer. I have found that doing that, we'll go ahead and turn off the black for a second so you can see. All the blue is just lines. The black is a fill. And I found that if you actually carve out and do the lines first, it makes it a lot better. The product ends up a lot better at the end because it's easier to remove all of the copper from the surrounding area. So now that we have these layers on, I'm going to go ahead and briefly show you what's going on here. I have it set for 1,000 millimeters per second in speed. The max power that I wanted to use is 90% of 60 watts. It's in the fill mode, and it's using a frequency of 30 kilohertz with a pulse width of 200 nanoseconds. The whole thing will be a global passive one, but this particular sub layer here, I have the cleaning pass turned off. You can see it in red right there. I have it turned off because I found that it's better to clean the whole board than just the outline of the board. So I'm gonna take that totally out in a future thing, but right now just totally disregard it. So again, speed of 1,000 millimeters per second. The maximum power is 90% of 60 watts. My mode is fill. My frequency is at 30 kilohertz, and my pulse width is 200 nanoseconds. Now, I know a lot of people don't understand what a Q pulse width is. What a Q pulse width is that all lasers pulse. So it is actually pulsing on and off 200 every 200 nanoseconds. Okay, so that's exactly what that means. Now, the longer the pulse width, the more it charges up. Okay, and fires a heavier blow. Okay, because it's able to charge up longer. Okay, to create that pulse. Okay, so I have a global pass of 1, but for this particular layer, I'm doing a line interval of 0.05, and that equates to 508 lines per inch. I'm going to start at a scan angle of 45, and I'm going to pass through it 3 times. So it's going to go through the whole thing 3 times. And then as it starts at that 45-degree angle, it's going to rotate its angle 90 degrees every single time. It's going to auto rotate. So the other layer that I have is the outline, and this is actually going to go 10 times, okay, at a speed of 1,000 millimeters per second, and it's at a max power 95%, frequency of 37, a Q pulse width of 200 nanoseconds, global pass is 10, and that is how we're going to outline the whole thing first. So now that I explained all that, let's go ahead and set up everything onto the fiber laser. We'll go ahead and say okay here. We have those 2 on. We also want to go ahead and turn on our clean pass. And what our clean pass is going to do, you see it's the whole entire board, and that is set to 1,500 millimeters per second at 20% power at a frequency of 100 kilohertz. Okay, still a Q pulse width of 200, and it's only going to do it 1 time, and it's going to scan at a 45-degree. Okay, all right, so we'll go ahead and say okay with that, and I only have those 3 layers on so that we can actually just, do the front side. Okay, so I will now turn over to the laser cam. Okay, and remember, this is just a base plate, so it doesn't go all the way through. This is the actual printed circuit board that we're going to create. This is the jig or the template that holds everything in place, and I'm going to go ahead and place the piece of printed circuit board into the template area and make sure that all right, now we have everything in place, and we're going to go ahead and we are going to turn on our frame, and it's going to frame everything out. And what we want to do is make sure that the outside lines are directly on the cutout within the template. Okay, so now that we have that, we're going to make sure that our fume extractor is on, and then we are going to go ahead and hit start. You guys can enjoy some music while you watch this thing blow up some copper.
Some say real men don't cry, so why the hell do I?
Pretty satisfying, isn't it? Pretty cool.
All the king's horses, all the king's men couldn't put the dreamer together again. Whispers, if you want me, say it for real. And I don't know what happens between the night and day. Neon sunrise over Broadway, my voice disintegrates. Came to the stage wide-eyed, chasing down a dream, like the wanderer on an overcrowded street, breathtaking, singing love story in a bar, wishing you were fast asleep in sweet Kentucky. And I don't know what happens between the night, between the day. I watch the sunrise over Broadway. And I don't know what happens by way of Boston and Chevrolet. I watch the sunrise over.
So this is about finishing up with the, now it's actually gone over to the cleaning layer, and what it's doing is it's actually removing all of the carbon and soot from the board. You're not going to really see a big, huge difference with the camera there. And it's actually going out of focus a little bit here. We'll fix that. We have new cameras coming. But you have to clean it up, because if you don't, then the solder mask could have problems. So having that done, doing the cleaning layer, it's pretty functional, and I absolutely recommend that you do it clean. Some people don't, some people do. I've had problems with putting on the solder mask and it sticking in certain areas because of carbon left behind. From the laser actually obliterating the copper. It doesn't really take that much longer. You talk about a minute and a half to do a clean layer. And we just did 3 separate layers in, I guess, 7 minutes. Doesn't take very long. So once this side is actually complete, what we're going to do is we're going to remove any of the particles and such from the area, and we'll lift up the printed circuit board and we'll turn it over to the other side, and then we'll go ahead and turn on the layers for the back side and cut the back layers. All right, so now that the front layer's over with, we're going to use a brush to remove any of the left-on particles of copper that might be stuck directly onto the board. Kind of, don't be too rough with it, but be brisk enough, to get things off of there. And then we're going to also use a blowgun to get all the rest of the particles out. And this also will help you lift the circuit board from the seated area there. Sometimes it can be difficult. So then this circuit board was designed to be flipped directly over. So this is the top of the board and this is the bottom board, left and right. So we flip the board like a page and we put it right back into the template to get the back side of this particular circuit board. So with that said, we'll go ahead and turn off the layers for the front and turn on the layers for the back. And that will also take about 5 to 7 minutes. So we'll be back as soon as that's done.
I wish I knew 20 years ago, so before I went blue. I've been waiting for someone to cut me loose. I didn't recognize those sad-eyed eyes. All along I was you. I've been kicking the can way too long now. I've been kicking the can way too long now. Peace, say hello to heaven. Searching for the boy I once outgrew. Those days when everything went to 11, I can honestly say I cried the day that Chris Cornell died. And I've been kicking the can way too long now. I've been kicking the can way too long now. Fuck, I wish I knew 20 years ago or so before I went blue. I've been waiting for someone to cut me loose. I didn't recognize those sad eyes. All along I was you. Those sad eyes. Some say real man don't cry, so why the hell do I? I've been kicking the can way too long now. I've been kicking the can way too long now. I've been kicking the can way too long now. I've been kicking the can way too long now. Fuck, I wish I knew 20 years ago or so before I went blue. I've been waiting for someone to cut me loose. I didn't recognize those sad eyes. All along I was you. I didn't recognize those sad eyes. All along I was you. Those sad eyes. Some say real men don't cry, so why the hell do I? such a lovely trick. I do a handstand, nanny on a manic path.
Alrighty. So now that that's done, we have both sides done. We're going to go ahead and do the same exact thing we did on the front side. We'll go ahead and use a brush, kind of get everything straightened out there, get all the debris off. And then we'll use a blowgun, kind of blow everything off. And then we'll blow underneath to get the circuit board off. And it looks pretty good. You can see everything's looking pretty good so far. You know, that's the back side. And there's the front side. So the next thing that you have to do is you have to check the circuit board to make sure everything is good and that continuity happens in the right places. And we'll turn this down just a little bit. So we're going to go ahead and switch over to the microscope. We're going to, first we're going to close off and stop framing everything. And then make sure we turn our layers off. And then hop over to the microscope. And now you can see what it looks like when a bad setting does certain things. So in here we're going to start looking at everything, and you can see how some of the edges and some copper is left over in the middle there, and you can see that the copper is actually touching still the other traces. So in order to fix this, what we actually have to do is use a razor blade or another tool. I use razor blades. It actually is better for me to use razor blades. So we're going to use a razor blade. Remember, this is a very small X-Acto knife that I'm using, just to give you an idea about how small the traces are and how little copper actually exists on the board. So here's the razor blade. Let me make sure it's clean. Okay, you can go in here and you can see how some of that, so this is what I'm talking about, the carbon left behind right here. Okay, so in these traces, this one still has a lot of copper left over. So we'll start at the top here and we'll just trace down and get the razor blade in the proper place. And we'll just trace straight down that line. And do it a couple of times to make sure that we have no copper connecting, creating continuity between those two. Okay, you got to make sure you keep the blade into the proper place. It's a little bit difficult for me because I'm used to doing it without looking at a monitor. But I have to look at a monitor because it won't be, it doesn't, this particular microscope doesn't allow to have on the monitor of the microscope itself, and giving on HDMI at the same time. You got to be very careful not to break the other traces. Oops. over that real quick and get those traces done. So you can see how difficult this is, and also how little copper exists on a printed circuit board. So next time electronics go up, just remember there's a lot that can go wrong. So let me go ahead and remove some of the debris in there. All right, so you get the point of that, okay? We'll come back to that. I feel that I can't really do it well while I'm actually looking at a monitor as compared to looking at the scope, looking through the scope. So we're going to go back over and we're going to go on to the next part of this, and that is going to be, as I said earlier, is to drill the holes and then go ahead and remove the solder mask off of the pads. Now, because they're so, excuse me for 1 second, I'll be right back. Sorry about that. I had to clear my throat there. But so, you know, there is such a small amount of copper on these pads. You have to be very careful of the settings when you're drilling holes all the way through. Now, I've done this a lot of different ways, and I find that the best methodology is to drill halfway through the board, turn the board over, and drill again. Okay? But you got to be sure of your settings and how you have everything laid out that you reverse the board, you know, so you can drill through the other side. So what we're going to do is we're going to go ahead and place a finish board with the solder mask already placed on. Okay, and you don't want to drill the holes before you have the solder mask. And so we're going to go ahead and put this in, and we're going to line everything up. And let me remove everything, clean up a little bit. I want to make sure there's nothing in the way. Okay. Okay. So we'll go ahead and put the template back in, jig everything up, make sure it's nice and square. We'll go ahead and put the finished circuit board in that has the solder mask on. And then we are going to turn on the drill holes small and drill holes large. And then we're also going to turn on the cleaning layer again. Okay. So this is pretty cool because it fires pretty quick. Okay. And let me make sure I got everything correct. Drill hole large, drill hole small. Okay. And then we're going to go ahead and frame. And you can see the framing going on. I want to make sure that everything is fairly lined up. And this looks a little off to me. So I need to make some adjustments. That's better. Okay. Up right, all the way into the right place. And make some adjustments this way. This wrong way. Just the other way. like it's gonna be good. Go to pads. Okay. I believe that's good enough, so we'll go ahead and hit the start button. You'll really like this one. It's like Star Wars, man. So we have it set for 50 times, and the reason why we do that is because if you use too much power, you'll blow the pads directly off of the board. You don't want that to happen. Here goes the cleaning layer. So normally what you would do next is remove the covering from the solder pads, but we're going to go ahead and drill the rest of the holes all the way through by flipping it over, and this is the first time I've done this particular board, so if it doesn't work out, I have to redo some calculations and try to get it right. The board will look pretty ugly, you have to use silk screen to do the solder mask, and then you have to cure it with a UV lamp, and it looks kind of rough. Yeah, it looks good, but it's still kind of rough because you're putting goop on the board. But after the cleaning pass, as you can see, it cleans it up and it looks really nice afterwards. It also gives you the ability, because you have to do more silk screening to put the print on the board itself of all, where you want resistors to go, blah, 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 blah. And that's all silk screening. So once you actually do a cleaning pass, it gives you a good layer to do the silk screen for the printing onto the board itself. Alrighty. Now that we have that, we'll go ahead and hold the template. Take the blowgun, just blow everything. Get that thing out of there. That looks really nice. Okay, so we're going to go ahead and turn it over and get it onto this side. Remember, you're just flipping it like a page. Make sure everything's jigged up properly. Go ahead and look at it. Oh, and we gotta close these layers off. And we'll turn on the drill small holes reversed, drill small holes, large holes reversed, and we'll frame it out again. And this time, we'll take a look at what's going on here. Thing looks to be fairly good. Hang on for a second. I'm going to turn off a couple of layers here just to take a look at this thing too. I'm going to go ahead and do it with the large fingers. It looks good. Alright, we'll turn everything back on. And we'll hit start. We're just drilling the holes on the other side. There's 50 passes again. And this is going at 1,300 millimeters, 1,300 millimeters per second, and at 85% power, 37 kilohertz. Again, you don't want to go too heavy on the power because you'll end up just blowing the pad straight off the board. Get the small holes done next, and that's also 50 passes. That looks pretty cool. And then the cleaning paints. We'll let you enjoy some music. As that finishes up, we'll go ahead and pull out the blowgun again. Kind of blow everything off. Get underneath. And get this to lift up the board so I can get it out easily. And now inspect the board to make sure that all the holes went through. Man, they did pretty good. And then we also have to look at the tiny holes. Looks like the tiny holes didn't go all the way through. So, did they or didn't they? No. All right, so what we'll do in order to fix that problem is we'll go ahead and stick our guy back in there with, oops, wrong way. And we'll stick the front side as we had it before. Not the rear side, the front side. And then we will go ahead and turn off all the other layers. And turn on the layers for just the drill holes small. And we'll go ahead and frame it. Let's make sure that everything's jigged up all right. All right, looks good. We'll hit that guy again. And just for shits and giggles, we'll hit it another time. All right, we'll go ahead and blow the board up. Get that guy out of there. And then we'll look. Yeah, those small holes went through that time. All right. So we'll go ahead, jig everything up again. Front side. Getting back in there. Make sure everything's at the right place. We'll turn off the drill hole small layer, and then we are going to turn on the front mask removal. Okay. And then we'll frame it. And then we'll hit start. And what this does is it removes the solder mask from just the pad areas. Take a look at it and see how it did. I need my flashlight to see in there a little bit further. And I think I'm going to go ahead and hit it another time. It doesn't, it's low power. So we'll go ahead and hit start again and let it rock on through. All right. Now that that's done, we'll go ahead and blow the board off again. Flip it over. I'm going to inspect it, before I put it back in here. Looks pretty good. So we'll go ahead and flip it over for the back side. Make sure everything is jigged up again. Turn off the front side mask. And turn on the back side mask. Frame it and hit go. We'll go ahead and hit it again. And now you have a completed printed circuit board, except for you got to still do the silk screening for the labeling. White. It'll be a white labeling to where components go. And the board's ready to go. Go ahead and pull this off. All right. That did very, very, very well. You can see how the board looks. And we're all ready. All righty. So that concludes this broadcast, and hopefully you learned something about what was going on, about how you can do this. Hope you like the show. And, give us a follow, give us a like. Help us out. You guys have a great day.